In this question, we have a strontium atom that gets turned into a strontium ion. So we're starting with strontium, Sr, and we're ending up with strontium 2+, Sr 2+. So our goal is to balance this reaction using electrons. So the key to balancing our reactions is looking at the charge. The overall charge has to be conserved. So the charge on the left of our equation and the charge on our right of our equation have to be equal. So right now on the left we have a strontium atom. It's not an ion, so it doesn't have a plus or a minus, it's just an atom. That means it has a charge of 0. On the right, to start with, we have a strontium 2+ ion, so that has a charge of 2+. And we need to add electrons somewhere in our equation so that this will balance out. Remember, electrons have a negative charge. So right now I have a charge of 0 on the left, 2+ on the right. Now since electrons are negatively charged, they can either be used to make the charge negative overall, or they can be used to cancel out a positive charge. So in this case, I'm going to add 2 electrons on the right-hand side, which is going to contribute a charge of 2-. So now on the right, I have 2+ and 2-. Those are going to cancel each other out to give an overall charge of 0. So now my overall charge on the left and on the right are the same. They're both 0, which means our equation is balanced. So we can fill out our answers now. We had strontium on the left, and we had strontium 2+ plus 2 electrons on the right. In 1 unit of this reaction, we had 2 electrons transferred. So what that means is that our strontium atom lost 2 electrons to become a strontium 2+ ion. So did the strontium atom gain or lose electrons? Well, we can see that it lost electrons since we have electrons given off on the right-hand side of the equation. Was this oxidation or reduction? This is where I'm going to use my mnemonic to help remember this, which is oil rig. And that helps me to remember that oxidation is loss of electrons and reduction is gain of electrons. So in this case, we have loss of electrons, and that means that our strontium was oxidized. Let's do one more question of this type. In this question, we have a phosphorus ion that gets turned into a phosphorus atom. So on the left of our equation, we have our phosphorus ion, P3-, and then on the right of our equation, we have our phosphorus atom, P. So again, we need to look at the charges on the left and the right. To start with, on the left, we have 3-, and on the right, we have just the phosphorus atom, which will have a charge of 0. And we're going to have to add electrons so that this balances out. Now remember, electrons are negatively charged, so they can either make something negative or they can cancel out a positive charge. So in this case, we're starting with a negative charge on the left. So if we add electrons there, it can't cancel out that negative charge. It's just going to make it more negative. Whereas on the right, we have a charge of 0 to start with. So if we added 3 electrons on the right-hand side of our equation, that would have a charge of 3-. That way, our overall charge on the right is 0 and 3-, which is overall 3-. And our charge on the left is 3-. So our charge is the same on the left and the right. So that means that our equation is now balanced. In this question, we have a strontium atom. So to complete our half equation here, we had P3- on the left, and we had P plus 3 electrons on the right. In this question, we have 3 electrons transferred. And we can see our P3 minus ion lost 3 electrons to form a P atom. So we have a loss of electrons, and according to oil rig, a loss of electrons means we have oxidation. So this example is also oxidation. If instead we had our electrons on the left, that means it was gaining electrons, and that would be reduction.